Hello, everyone. The story of Kurashiru developing a personalized recommendation system with Snowflake. My name is Yuya Harigae from Delhi. I am Harry. Very nice to meet you. First, let me introduce myself. I am from Delhi, Kurashiru company. My name is Harigae. I'm a data manager. Everyone calls me Harry, so please call me Harry too. In 2021, from August, I joined Delhi as a data engineer, responsible for building a new data platform for Kurashiru. And currently, I work as a data engineer with Scrum Master as well in the personalization related team. And lately, I was selected as the Snowflake data superhero from the community. So I am very active in the community as well. Here's the agenda for today. First of all, our product, Kurashiru, and why we are using Snowflake to build the data infrastructure, data platform. And then this data platform and how we built up data pipeline. And also for Kurashiru product, how we are using the data from the platform for personalized recommendation function. So before going into the session, I'd like to talk about why we started to build this data infrastructure. That is because we are focusing on personalization. We are talking about Kurashiru. So here is the product, Kurashiru. Just very briefly, I'd like to explain. This is number one, a recipe platform service in Japan. And the mission is to bring happiness to 8 billion people 3 times a day using recipe videos. A lot of people are enjoying at this platform. So up to now, mostly Kurashiru's chef supervised recipe content was the focus for the distribution to users. And it was very popular among the users. But not only those recipe videos, since last year, we have the new recipe posting functionality released so that we can use a lot of content from creators. Using kurashiru, a lot of users are enjoying the content. So why personalized recommendation by Kurashiru? Why the focus? Just very briefly, I would like to tell you some examples. In terms of kurashiru recommendations, there are some difficulties. For example, for ordinary recommendations, for example, you have this e-commerce site and also video distribution services. And suppose a user purchases or looks at this product, and when you recommend, most likely he or she looks at this recommendation or recommended site. But when you use kurashiru, it's a very difficult situation. For example, suppose a user looked at kurashiru to cook curry rice. So this person likes curry. So can you recommend curry again for tomorrow's recipe? He or she might say that I cooked curry yesterday, so maybe not today. And I would say the same. Yesterday I ate curry, and even if curry is recommended for tomorrow, even if I love it, maybe I don't like it. So even if you recommend in this food area, in Kurashiru's area, it's very difficult to recommend a certain recipe. Maybe they have some leftover and he loves curry. Maybe he cooks curry next day too. But suppose he has only onions, and if he really likes curry, maybe he cooks curry again. But he has onions and he looks for some different recommendations, so he cooks something different. If I were the user, I just search for onion recipes, and then rather than being recommended curry, I would be satisfied using some other recipes. That is a very difficult part of recommendation using Kurashiru. In that sense, so even if we use new methodologies such as machine learning, recommendation of kurashiru is very difficult. Historically, in kurashiru, there was a discussion about this, and this was a challenge for us as well. So these are the challenges. How kurashiru decided to have this recommendation function. Up to now, in kurashiru, well, me as well, we used to focus on easy cooking recipes and microwave recipes. They were very popular among many users. For example, on the right side, the big one, there were a lot of users in this part. But as I mentioned before, there are so many users posting a lot of different contents. And then we would like a lot more users to use these different contents. And other than that, we used to have easy cooking genre and microwave recipes, calendars. Well, we would like to have a variety of users covering a lot of different recipes. This is a very important role. So personalized recommendation should be very important in that sense. And when we can realize that it's not only for food, entertainment as well, including kurashiru, we can have personalized recommendation for everything that's covered by kurashiru. So not only Japan, people in all over the world can use the platform kurashiru. So there's a great potential. So for this personalized recommendation, what is the most important thing is this data platform. Data platform and quality data, performance data, and then for personalized recommendation, this is the very first, very important point.
So far, I have explained why we are trying to put emphasis on recommendation and what is the data infrastructure or platform that's most important. So I would like to go into the technical areas. First of all, we had data platform for analysis, and it looks like this. AWS environment is where it is built. The user action logs and other contents-related data are actually in the storage of the S3 coming from Kinesis Firehose, and then it flows to the right, and then at the end they will be subject to analysis using BI tools, and we can actually get some insight as to the user's activities or behaviors. Now, such data and platform has been in place for a few years already, but for analytical purposes, it's been optimized to the maximum. It is already a very good data infrastructure or platform for analysis. For example, KPI and effective verification, the necessary data, as well as the different skill sets are already in place. Queries can be written by non-engineers, and PDCA can be followed with the existing data platform. And there were no failures, major faults or failures. And in daily management, of course, data chaos and data qualities had some issues, but if you let go of it, then I think it was acceptable level of data platform that we had. However, having said that, when we think about future features that the data platform will be used for example, recommendations, then there will be bottlenecks already. And let's say data platform will receive the action or behavioral information, but it takes about 3 hours to do this processing. Storage has to be dealt with, and there's this back and forth, and that it was a bottleneck. And then when we were using Athena for analyses. But the performance, such as the concurrent execution number, for example, among other performance indicators, would be quite a bottleneck. In other words, we need to have more power or scalability. And so once again, data platform to date, as I have explained, there were 3 major challenges. One is code log real-time analysis was not possible. I said 3 hours that was required. In case of kurashiru, about 300 million records of data is stored. That's the nature of the platform. And so 300 million data records, how quickly can we bring them so that they can be analyzed, and can we do it in a cost-efficient manner? That's another issue. And also machine learning application might want to use this data. What about the scalability and the performance that is needed for that purpose? We believe that we're entering a phase where such a scalability and performance level is needed. And then what about the data engineering resources? We don't have enough. We don't have much in spare. In other words, data pipeline, the tuning can continue. However, if we are to try to increase the performance and the power, it is quite difficult to deal with what we have already, data chaos, including data quality issues. I said that we were able to accept it, but I think when we think about new applications and features going forward, it would not be good enough. So data cloud, Snowflake is what we looked at to really have a new or build a new data platform. And so we are really trying to achieve this. We came up with this to-be state in what we were striving for. So why Snowflake? Why did we choose Snowflake? These are the expectations we had for Snowflake. First of all, AWS environment can be used in developing or this platform in using Snowflake. The data infrastructure we had is already in the AWS environment. In other words, it is really easy for us to migrate or move the data to Snowflake, and therefore replacement or the efforts needed is very limited when we decide to use Snowflake. Let's say 300 million records of data per day. If you needed to migrate that to a different storage or to the cloud, transferring data alone, can we be clear about the cost benefit? It's rather difficult to make the case for that. And what's the benefit that you can expect? You have to really do a thorough analysis, and it was rather uncertain to really have that business case. And Snowflake, on the other hand, is a pay-as-you-go type of payment. In other words, you're charged for the usage. And if you don't use it, you don't have to pay, you just return it. So that's a positive in terms of agility. And so that was another positive aspect of Snowflake. And one of the characteristics of Snowflake is separating the computing resources between storage and calculation or computation. We thought that was really useful. For example, in the past, we were just using data warehouse or computing resources for analysis purposes. But going forward, applications, machine learnings, and other workloads will require computing resources. And when a computing resource is separated between storage and calculation, it will be quite positive in terms of scalability. And so that is another very important key point for choosing Snowflake. This is one of the things that we really wanted. And near zero maintenance is another characteristic that Snowflake is touting because it's almost maintenance free. And that's a big benefit as well. And multi-cloud. We can deploy it in multi-cloud. As I mentioned earlier, we have limited data engineering resources where we have to do various engineering and DBT, modern data stack, which is in fashion right now. Hot topic. I think we can actually focus on the tasks that really require engineering work, and so use Snowflake functions. I think we can explore new avenues with the use of Snowflake. So once again, I showed you this pipeline of the data. In developing that data, well, actually, it took myself, 1 month, 1 man month. Data pipeline is similar to what we had in the past. Data platforms, however, by having this new platform, what used to take 3 hours for analysis is now reduced to 1 minute approximately at the shortest. So 3 hours down to 1 minute or so. So what made it possible? Let me explain how that is done. So I said shortest 1 minute analysis that is realized by this pipeline using 3 major functions: Snowpipe, Stream, and serverless task. We're using these 3 features to realize this. So let me explain from the top. Snowpipe first. Snowpipe. In AWS, they have S3, GCS. These are the storage that are called stage. And when the file is stored, then automatic data load happens into the following tables. And so in our environment, the S3 in AWS Kinesis will actually bring the data, log data to S3. And so at that timing, then we can actually store the record in real time.
The next one is called Stream. This is tracking and memorizing function of the change history. This is Stream. For example, the previous table has data by Snowpipe, and then the data is detected, and there is processing toward the subsequent table. So this is CDC, change data capture data pipeline, using this stream. Because of the log data, basically, a Snowpipe brings data, and you have additional data, you have accumulation of log, and by using this stream, this accumulated new data can be put into the subsequent data after being processed continually. The last one is task or serverless task. A Snowflake task is a function that periodically executes batch processing, queries, or scripts. And by combining with Snowflake, the added data is accumulated here. And for the subsequent data, we can do processing using this task to be input into the subsequent table. And this continuous process allows data to be stored in analysis. But Snowflake charges according to the compute resource utilization time. However, because task execution can take as little as 1 minute before automatically stopping, micro-batching, the batch process at 1 minute intervals would require compute resources to run constantly. So the cost of using tasks to achieve the kind of near real-time implementation we wanted to achieve is quite high because it's always on. Compute resource is always on. So that was one of the unbeneficial points. To address this challenge, a feature called serverless task has recently been released. So I'd like to explain that. Serverless task can significantly reduce the cost of implementing near real-time data because, well, suppose there is a process that takes 6 seconds and that's charged for 6 seconds. In that sense, always on, rather than its cost performance is better because it's only for 6 seconds, and then always on environment and computing resources more efficiently used in terms of performance. The control is done, so we don't have to think about anything to implement serverless tasks. So cost performance is very good. So serverless tasks and streams are combined to make real-time data pipeline. So to summarize that, through such an example, cost performance is improved and in this data pipeline, and it scales accordingly. And as for maintenance, data quality and data cost, and when you check the daily operation, you don't need so much workload, tuning, or maintenance work. So after implementation, We have been operating this for about a year, and there is no big failure. And in terms of workload, well, the balance is very good. So this data platform is very good. However, we built up this data platform, but that was not the purpose of this session. Using this, personalized recommendations should be realized, and we have been thinking about it. So I would like to talk about this. So now we have the data platform. So the next one is personalized recommendation. So once again, kurashiru through food contributes to users by providing a lot of different content. And that is the value of kurashiru. That is a personalized recommendation. This is one of the motivation to realize that. We have a lot of content about food and life, and we would like to increase various different types of content, and we would like users to post a lot of content. And also we have to recommend the contents to users. So we need both approaches. So as for team members, to think about such kind of recommendations, we have to form projects, and we were doing development with PDM and client server-side engineers and content managers. And then I am here to answer questions about data. We have this data engineer, such as us, such as me, and we are doing development every day to think about recommendations to the users. This is part of the bottlenecks. As I mentioned before, data platform, unless you know a lot about Snowflake, you cannot develop. And well, when I am the only one who is answering a lot of questions, we reach bottlenecks. So how to solve this issue? As an answer for the recommendation, we established this kind of pipeline. And this is subsequent pipeline next to the pipeline I was describing before. The first one, I said real-time data and just-in-time necessary recommendation job was implemented on this pipeline. And when you create this data only, you cannot reflect this onto the kurashiru application. So this kind of recommendation data on the platform should be registered. And for that, AWS external function was used. So from server side to kurashiru, recommendation is fed. So this is an event-driven data flow that was created. And the last one is dbt. Using dbt, not only analysis, but data modeling for recommendation was done. So first about dbt. Sorry, this is too much in detail. You might not be able to see it. Data build tool is dbt. And this is T from ELT. T part, transform part. This is the transform part. This is a tool, dbt. A lot of people talk about dbt nowadays. So we are using tasks and streams for data pipeline implementation. But you need data engineers to address a lot of issues. But by having this dbt, this is top right query, you can see. By having this kind of query, you can do data modeling, and you can make the table. Only writing query, you can implement this. And also connecting with GitHub, and also data quality testing for deployment. In that sense, data engineering can be more agile. So this is why we are using it.
And I think there was an unexpected byproduct when we decided to use PDT. All we need to do is write the query, so it looks like this. So it's not just data engineers that can do this. Actually, as long as people can write queries, they can actually develop this DBT. In other words, data engineering, which used to be limited in terms of the people who could do it, actually the recommendation-related data could be actually handled by other people as well, as long as they could write the queries. So that was the positive aspect. And I'm skipping one slide here. No, not this one. I should talk about this one too. Excuse me. Okay, so DBT to be used to develop the data pipeline. I mentioned that. What about Snowflake data pipeline versus a DBT pipeline? How should you differentiate between the two? Let me elaborate on that a little bit. So Snowflake pipelines. This is very much like data engineers, so it might be limited to certain engineers. Snowflake pipeline, if you choose to take that path, then it would be for situations where real-time is necessary, and also cost performance is important, rather than analyzing the data, but maybe data cleansing in upstream, especially maybe Snowflake is useful for that purpose. On the other hand, DBT, you have to think about the kind of analysis that you want to do and how you want to tie it to recommendations. In other words, more business-oriented considerations, not so much requirement for real-time performance, but rather more importance on quality. Then a DBT data pipeline might be to be chosen. So DBT real-time data pipeline is possible, but maybe that's not a subject for today's discussion. I will save it for later at a different date. Now let me just talk about the recommendation. Kurashiru's recommendation process. Well, machine learning is not really to be introduced in a full-fledged fashion. We're still thinking what sort of recommendation we should offer. So a naively implemented recommendation in the data pipeline is what we're thinking of. So DAG or DAG is also used as an approach. Once we have the necessary data, we do the pre-processing, and then the recommendation logic will have that fed. Will eat that data, and then on the server side database that will be stored. So user actions will actually be kept in the log. It will be sent. Server-side database will store that. So it's this series of flow of data. So machine learning is not really introduced yet. However, I think we are sort of developed enough or advanced enough to really think about machine learning going forward. Let me now talk about external functions. Data warehouse of different sorts have been providing this function or feature of external function. External API can be called using the SQL servers. So oftentimes, external API can be used for translation from Japanese to English. You input Japanese and then you get the response in English. In other words, external service is leveraged, and there is this good linkage of the data to realize such a transaction. Now we have developed this external function in the AWS environment, and that was the data that was recommended is posted onto the server side. That is really the sole purpose of that function. Now, reverse ETL is often talked about. It's in fashion right now. But we are using our own reverse ETL type of external function. What was good about that was that event-driven data feeding is possible to the server side. Or actually, originally, typically, you would actually get the data on a periodic basis from the server side. However, once the processing is done in the data pipeline, we can actually distribute the contents. So that is event-driven, and that's quite a positive element. So I have just explained this flow of data being sent that would be provided for the sake of recommendation. I hope you followed my explanation. But let me also talk about what we are thinking of doing going forward. Of course, we would do recommendation, but what else? Well, as I have said, data pipeline-based naive recommendation is what we have already implemented. But for sure, we need to focus on machine learning. I think we're in that phase already. As I said from the beginning, attractive contents in a more personalized fashion should be included in the user recommendations. And that purpose is unchanged. And therefore, our challenge is to think about the various services in Snowflake included, what we can do to offer that personalized attractive contents to our users. We are determined to realize that. But let me just give you an idea as to what we think is possible. I mentioned the external function that can have a good link with the external API, AI services or API or ML model that is managed outside. And then using the external function, maybe we can link such data so that on a real-time basis, we can have event-driven kind of machine learning pipeline of some sort. That is one possibility we're envisioning. And more recently, the Snowflake on Python, that's called the Snowpark for Python, which was GA released recently. We can even maybe develop this machine learning pipeline on top of the data platform. So that's a possibility, and we think that this is a very interesting and exciting period that we're living in. So we're taking on various challenges so that we can create contents that are very unique to kurashiru and also offer recommendations to our users. Thank you very much for your kind attention. Thank you very much, Mr. Harigae. From here on, Plus Talk is going to follow. We're going deeper into the contents of the presentation, and we would like to entertain some of the questions the audience might have. So if you have any question, please click on the question mark at the bottom on the right-hand side of the screen to send in your questions. And Mr. Keigo Kubo of Align will be the interviewer.
Hello, Machine Learning Solution Team 1. My name is Keigo Kubo. Thank you very much for your time. Thank you very much for the presentation. I have a question. So first of all, up to now, machine learning model was created, and you had a lot of different approaches you tried. And up to now, what kind of challenge setting and approaches did you have? And did you have any trigger to use this data platform? Yes, up to now, we had a lot of recommendation approaches using ML. And we want users to use a lot of different types of contents. But rather than that, we were thinking about, for example, before I said a user who cooked curry before, and what about the next day? And there was such a recommendation we focused on. But this is a very difficult question for the machine learning. But by giving this recommendation, what did you get? It was difficult for us to evaluate. So that was one of the challenges for us. That was very difficult. And what was another question? What was the trigger for you to have achieved this data platform? Did you have any setting of challenges? In terms of real-time system, I think it's close to that. We want users to enjoy the contents more. For example, data after 3 hours. Well, I think it's rare for us to have users who are using kurashiru for 3 hours in a row. So we want more contents, but the data volume increases. So to solve such kind of challenge, we wanted to renew the data platform. That was a trigger.
Thank you very much. other questions includes Snowflake DBT introduction. You talked about those. I think there were a lot of positives that you mentioned, but in introducing them initially, you had some expectations, but were there any gaps as to what was different from your expectation? Were there pros and cons? Well, as far as we're using it, do I identify any difficulties or shortages? No, I don't think there were any. For example, in terms of cost, we pay as we use. So without any usage, we're not charged. Therefore, we're not spending or wasting additional cost. We're just paying for what we have used. And also in performance, there were no drawbacks. So what we had expected have been provided, I think. Okay, I understand. Thank you.
そうですね。他に質問
Any other questions? I would like to pick up some questions from the audience. I don't think there are too much difficult questions. I'd love to answer your questions. About reverse ETL data API for one person or all customers. Because of the real-time approach, it would help us. As for API, we return the necessary lists. For example, in terms of the database usage, sometimes we have challenges, but we will have to think about how to return that. Thank you.